Math Blast 27, Patterns. What rule is the function machine using? Well, in the input, I see 3, 6, and 9. And so when these numbers are put into the machine, what happens for the output numbers 12, 24, and 36 to appear? That's the idea here. So to get from 3 to 12, I know I could multiply by 4. Let's see if that works all the way through. 6 times 4 gives me 24, and 9 times 4 gives me 36. So we found the rule. Input times 4 equals the output. I'm going to write the rule here. Input times 4 equals output. Bar graphs. How many more students have birthdays in June and July than in August? Well, as I look at my graph here, I notice the title, Birthday of Students by Month. I see on the horizontal axis, labeled month, that we have each of the months January through December. On the vertical axis, labeled number of students, we have a scale going from 0 to 12, counting by twos. I'm looking for students who have birthdays in June and July. In June, there are 10 students with birthdays. In July, there are 6 students with birthdays. So in June and July, there is a total of 16 students with birthdays. I'm going to note that here. June plus July equals 16. Now in August, I see in August, there is 1 student. It hasn't made it to the 2, and it's not at the 0. It's right in between those. So 1 student. All right, so if I want to figure out how many more students had a birthday in June and July than in August, I can take 16, subtract 1, and find 15. I'll note here, 15 more students. Line plots. McKinsey measured pieces of straw and recorded the data below. The line plot starts at the 8-inch mark. Use X's to show the data. Notice the line plot starts at 8 and ends at 10 here. We find 9 right in the middle. And each of the numbers are increasing by a fourth. So let's put an X above each time the number appears in our data set. Straw A is at 9 inches. I'll put an X above that. Straw B, 8 2/4 inches. Straw C is at 8 1/4 inch. Straw D, 8 3/4 inches. Straw E is 9 inches. Notice we already have an X above 9, so we're going to put a second X here. We stack our X's when that number appears in the data set more than once. And straw F is 9 2/4 inches. There is our line plot for the given set of data. Area, tiling. Find the area of the rectangle by tiling it. So here, what I'm going to do is complete the columns. Just continue drawing my lines down, and then I'm going to complete the rows by drawing this one over. And I can count all the squares that make up this two-dimensional figure here, and that gives me the area. I see also there are 3 rows, and in each one of those rows there are 6 boxes. So I can go 6, 12, 18. Or I could count them individually and find that there are also 18 squares. So the area equals 18 square units. Area of rectilinear figures using the distributive property. Find the area of the figure. Labeled measurements are in inches, it tells us. So each one of these numbers here are represented as inches. Well, I know I can find the area of this square as 4 rows of 4 in each row. If I counted all the boxes that would be created in there, it would be 16, because 4 times 4 equals 16. And we know that this is 4 inches by 4 inches. And so it's 16 inches squared, or 16 square inches. You can write that either way, doesn't matter. Now for this figure here, I have 2 inches and 3 inches here. So let's go ahead and jot that down as 2 inches times 3 inches. We want to take our length times width, and we get 6 inches squared, or we could write that as 6 square inches. Now we want to put that together. So we have 16 square inches plus 6 square inches. And so that gives us 22 square inches. That would be our total area, 22 square inches.